Hello everyone, this is Nikhil, third year BTech student of GRIT. I am going to give presentation about our mini project prediction of sepsis using enzyme techniques. The team members are V. Niket, Mohammad Samir and P. Yashwant Reddy. Our team guide is Dr. N. V. Ganpati Raju sir. Coming to abstract, sepsis is a life-threatening condition that occurs when the body's response to infection that causes tissue damage, organ failure, or death. The sooner septic patients are treated, the more likely they are to survive. But sepsis can be challenging to recognize. Therefore, it is crucial to detect and treat sepsis as early as possible. To achieve early detection, we can use various data sources like electronic health records, EHRs, lab test results, and many other models. These models uses ancillary techniques such as bagging classifiers and random forest classifiers. Our goal is to predict sepsis 6 hours before it would clinically be diagnosed. Early prediction can be life-saving, while late predictions can be harmful, wasting the hospital's resources. In our study, we analyzed data from over 60,000 ICU patients, extracting up to 40 clinical variables. The main objective is to identify sepsis as soon as possible as patient arrives in the emergency room, potentially giving life-saving treatments. Existing system. The early detection of sepsis primarily relies on artificial neural networks such as RVFNN, recurrent neural networks, and long short-term memory networks. The several challenges faced are slow computational speed, limited accuracy, and training complexity. Proposed system. The proposed random forest classifier based system offers significant improvements over the existing ANN based models for the early detection of sepsis by addressing key limitations such as handling long sequences, computational speed, gradient issues, and training complexity. The new system promises more accurate, efficient, and reliable predictions, ultimately aiming to enhance patients to overcome and reduce sepsis-related mortality. Now let's look into UMR diagrams. Activity diagram. We use enzyme techniques to predict sepsis by collecting and pre-processing patient data, then extracting key features for model training. After validating the model's performance, we deploy it if it meets the criteria, or adjust and retain if necessary. The deployed model processes new patient data in real time, assessing sepsis risk continuously. High-risk predictions trigger alerts to medical staff and initiate the sepsis protocol, ensuring prompt treatment. For low-risk patients, the system continues monitoring to maintain patient safety and improve outcomes. Sequence diagram. In the first step, the dataset is pre-processed to remove noise, ensuring clean data for modeling. In the second step, the dataset is split into training and testing sets for model evaluation. Then, the sepsis detection model is trained using the training data. After that, the trained model is tested using the test data to evaluate its performance. The user sends a request to the API for sepsis prediction. In the next step, the API transfers the user's data to the sepsis detection model. The sepsis detection model reads and processes the user's data. The model predicts the sepsis risk based on the user's data, and then the predicted results are sent back to the API. Finally, the API displays the prediction results to the user. Next, the system architecture. The system architecture illustrates a three-tiered system for predicting sepsis using machine learning. First, client type. It contains two components which are clinical data and diagnosis result. Clinical data. This represents the input data collected from patients, which includes various clinical parameters and observations. Diagnosis result. This is the output provided to the client, which indicates whether the patient is predicted to have sepsis based on the input data. The next type is logical type. In this, the first component is data pre-processing and feature importance. This module is responsible for cleaning and preparing the clinical data. It involves tasks such as handling missing values, normalizing the data, and selecting the most relevant features that influence the prediction of sepsis. In the next component, that is training the model. In this step, a machine learning model is trained using the pre-processed data. The model learns to identify patterns and correlation in the data that are indicative of sepsis, generating the diagnosis. Once the model is trained, it can be used to generate predictions. Given new clinical data, the model will output a diagnosis result, indicating whether the patient is at risk of sepsis or not. And the last tier is data type. It contains the two components that are clinical sepsis dataset and target data. Clinical sepsis dataset. This is a repository of historical clinical data related to sepsis cause. It is used for training the machine learning model. Target data. This is the dataset used for testing the model and generating predictions. It includes new clinical data that the model has not seen before. Now, let's come to the code part. Implementation. In the first step, we are importing all the required libraries like confusion matrix, which is used to evaluate the performance of a classification model by computing the confusion matrix. Random forest classifier, which is an ensemble learning method for classification that operates by constructing multiple decision trees. The bagging classifier, which is an ensemble method that fits multiple base classifiers on random subsets of the original dataset and then aggregates the predictions. And in the next step, we are splitting the data into training and testing dataset. After that, we are importing the training and testing datasets. These all are the different columns and variables of the dataset which we are importing. And we are listing out the unique patients of the patient ID variable. And these all are the percentage of null values that are present in all the parameters. After thorough analysis of the data, it was found that a lot of the features were redundant, and so it is required to drop the columns which are not required for the model. Imputation. Since there are a lot of missing values in the dataset, the imputation was done to fill the variables. And we repeat this process 2 times to take the only variables which are required for building the model. Let's go to the model building. So in this function will transform the data frame in the compactable. After this function calculates different evaluation parameters of a model. Once the model is ready, then we are checking the distribution of data points between the two classes, where we have two classes which are number of sepsis label, one which indicates as true, and while the number of sepsis label 0 which indicates the false. So by comparing the classifiers of ensemble techniques, we can conclude that random forest classification has more accuracy than other classifiers present in the ensemble techniques. Thank you.